fin that they don't actually need. They don't want to cut off the whole tail. Why not? Yeah, that'd be kind of hard on the fish. And just actually doing what they do to the fish is sometimes some of the fish die. There is some mortality that we have to worry about. But I wanted to talk about this procedure that you're doing is really important in a lot of situations. One is in animal populations. With birds, have you maybe seen or heard they'll put a tag on the leg of a bird, and they'll catch them with nets or however they might catch them, and then release them and then hope to see if they can find them next year. Butterflies do these big migrations, and they actually have ways to tag a butterfly so that they can identify it, but it has to be something pretty lightweight, right? Can you imagine a butterfly trying to drag along a big piece of metal or something to identify it? That's tough to do. It's used in other places too, in studying disease in humans. They might wonder how many people out there have hepatitis. And they do something very similar to what you're doing, where you measure people at one point in time, and then you come back later to see if they show up, how many new people show up. And that's kind of like mark and recapture. Or if you're in computer programming and you want to know how many bugs are in your computer program, you can be sure if you make a very big computer program that you haven't found them all. There are more in there. So they do something very similar by trying to figure out how many bugs there are now and then doing some more testing, figure out how many more they find, and it comes out with very much the same kind of data. These pictures are a German brown trout and the rainbow trout, which are both important species in Montana. And here's how they fish for them. They don't just put out a line and hope that the fish bites the hook. How many of you have done that? Good. Did you enjoy it?
Yeah.
Or worms, I don't care at this point. These guys aren't fly fishing. They have two poles of direct current. There's an anode and a cathode, and they're running a pulse current through the water. This woman has a backpack generator on her back that creates the current, and you can't see it, but there's a wire hanging off that goes into the water and gives one of the poles of the current. The other one is here on this loop that she has on a stick. And then you see two people are there waiting for fish to swim toward that. That's the anode, I think. And then they're going to net them with the nets. On bigger water, so this works on a little stream. Here's a boat that's doing the same thing. So the boat acts as one pole, and the anodes then are dropped into the water like this. And this guy is looking to see the fish swimming toward the anode. So the pulse DC current makes the muscles of the fish contract and stop. And so it's kind of mean. It makes them swim toward the anode. So that's electrofishing. It's not legal for you to go do that in the streets. It works too well for that. Once they net the fish, then they have to anesthetize them, and they have to weigh them and measure them to see how big they are. They do this all the time in Montana over multiple years. On the Missouri River, there are two sites where they do it. Blackfoot River, I've got data. The Bitterroot River, this is Rock Creek, which does not connect to the Bitterroot, but it comes close. Here we're on the Gallatin. There are a couple of spots near here, the Madison River, the Ruby River. And I have data from all those places. And the question is, what's happening to the trout? Would it matter to people if we didn't have trout?
Yes.
Why?
Because the ecosystem maybe might.
The ecosystem?
One of the main reasons tourists come to Montana is to fish. And so if suddenly all the trout disappear, there are the tourist numbers go down, and tourism is one of Montana's major
Right.
So if that went down, then our whole market, like our whole economy would crash, and it'd be really bad.
Wouldn't be too good. Have any of you been to the airport in the summertime? Do you see people carrying these big, long, round things? What's in there? Yeah, fishing poles, yeah, of various kinds. So it is really important to the economy and to the environment, the ecology. So we do want to keep the fish population healthy. There is something called whirling disease that appeared in Montana in the mid-90s, about 1995. And it's this little tiny thing. It's microscopic. Here it's blown up. So it's this microscopic thing that looks kind of like a hook. It floats around in the water, and if it finds a trout, a fish, it punctures the skin and moves inside. It's like an alien invader. And people who see it happen say it looks like it hurts the fish, because I don't know how much fish feel, but if they put them in water where there are these, they call these TAMs. Anyway, it's a big long name for triachinum. I can't say it. It's there if you want to read it. So that they go inside the fish and they eat the fish's cartilage. Especially, there's a lot of cartilage around in their head. And if it disturbs their inner ear, just like our inner ear, that's, do you know what the inner ear does?
Balance.
Balance, exactly. That upsets their balance, and that can make them swim in a circle. And it can also eat up cartilage in the tail, so this fish is deformed because it's been chewed on from the inside. The fish then dies and goes to the bottom of the stream or the river, and that releases spores, which are an entirely different shape. They're just this tiny little hard round thing. The spores have to find the tubifex worm that lives in the gravel, and it needs this whole loop to work. It has to go into the worm. The worm basically eats it, it goes through their digestive system, and it comes out and turns back into this form again. Isn't that a weird life cycle?
So does the original thing, is it just like out there, or does it come
Yeah.
from something?
This thing is just floating around in the water. It came from the tubifex worm, basically from its poop.
No, I know, but like, how did it first get in?
Oh, so yeah, this thing is saying, you know what piscivorous birds are? Pisca means fish. How about ivorous? You have carnivorous, herbivorous, yeah, fish-eating birds. So this might be an osprey. That might be one way that they travel from one stream to another. The bird might pick up a fish and chew on it and then drop some of it. I don't know, but yeah.
Can the piscivorous birds get infected
I
by
don't
it?
think so. I think it's only the fish and the worms.
Because they eat the fish.
Right. Right. And I don't know what happens when they poop. It's spores would go right through the bird. I don't know. Okay, so pretty weird. Can you imagine? Isn't it weird how evolution works? That some parasite could evolve and have that complicated a life cycle. Has to find the right things. There are lots of parasites that have complicated life cycles like that. There are a lot of complications. Did the Swedish fish stick together?
Yeah, sometimes.
Yeah. Are your fish all the same size?
No.
Yeah, so that happens when they're out there fishing. There can also be animals. So imagine if you're trying to trap a raccoon. You're going to mark it, let it loose, and then try to trap it again. If you have something really yummy in that trap, you know what do raccoons like?
Peanut butter.
Peanut butter?
I don't know. I made up.
You might get a raccoon that goes around looking for your trap and wants to get captured again, and we call that a trap-happy animal. that kind of messes up when we run the numbers, because we want to assume that we're equally likely to catch an animal that's been captured before as one that's not. So when you reach your hand in the bag, you want to be able to catch both kinds of fish, marked and unmarked, and it shouldn't matter, you know. But if you chopped them to be real small, I guess that would really make a difference, wouldn't it? So this is some of the stuff we have to worry about. With the trout that I'm working with, we split them into length classes. So they're all measured, and it was like we were pretending if they were between 4 and 5 inches, that's a different group of fish, a different population than those that are 5 to 6 inches. So we split it up into length classes, and what we're interested in is, can we tell what's happening with whirling disease by looking at this capture-recapture data over time. We've got time going back to 1980 in some of these streams. And then the disease came in around 1995 to 2000, depending different rivers, different times. And then looking at kind of a before and after. So that's what we've done, and it's a lot more complicated than the analysis that you're doing, which what you're doing, the step here would be to say, let's assume that the proportion that we captured, so when you did the second capture, you pulled some out, what proportion did you get the fish that were marked?
We only got 1 out of 8 marked fish.
Okay, 1 out of 8, somebody else?
We got 6.
We got 1 out of 6.
1 out of 6?
Got 1 out of 5.
1 out of 5?
2 out of 7.
2 out of 7? 1 out of 7? Or actually, you had 2 out of 14, didn't you? Okay, go ahead.
3 out of 10.
3 out of 10. We make the assumption that the proportion of fish that you saw when you pulled that out, 3 out of 10 or 1 out of 8, is the same as what's in the bag. How do you feel about that? Think that's exactly true? Probably not. But if you do that assumption, you can then estimate how many fish are in the bag. And an important thing is you're all going to get different estimates as you pull out different numbers, right? That's where statistics comes into things. And we're comfortable with the fact that when we do this, again and again, we'll get different numbers. And we know that's going to happen, and that's okay. We work with that variability. This is looking at different lengths of fish measured in millimeters from 150, which would be about 6 inches, up to 500, which would be around 18 inches. So from real small fish to big fish, looking at 4 different rivers. And on each of these rivers, we had 2 different sites we could compare. We also had 2 species, browns and rainbows. Except on the ruby, we only had rainbows. And what we're looking for is how much change did we see when whirling disease came into the system. And if you see things at 0, this is log scale proportion change. 0 here means no change. And we're using,
Smartboard.
touched it.
Yep.
These are kind of like error bars to say how confident are we in these. The thick part is we're about 50% confident in that middle part, and if you go to the ends, we're 95% confident. Things that are below the line are places where we saw a decrease at the same time the whirling disease came in. These are rainbow trout in the Missouri River. And these are the smaller fish. But if you look at the bigger fish, this is actually an increase because it's up above the 0 line. Yes?
Is that because the little fish are dying, so the big fish prosper more?
Well, we wonder, yeah. So they eat the same food. And if you don't have the little guys there to grab stuff, then the big fish have more to eat. Or maybe are the big fish chewing on the little fish? They do that too. So it's hard to explain just what's happening, but that's the result of a lot of stat work. And I'm not going to go into any details, but I am going to do this because it's fun. So I want to tell you that I think it's really fun to be a statistician. I want you to know about what the job is. When I first heard of statistics, I thought, oh, those are people who go out and collect all sorts of numbers and then they put them in a warehouse and lock the door or something, you know? That's not what we do. What we're doing is trying to understand how the world works. And the problem with the way the world works is there's a lot of variability. We call it noise in the system. For instance, you know, you go fishing one day and you catch a lot of fish, and you go out another day and you don't catch any at all. There's just a lot of variability. So what we're trying to do is figure out how to make sense in a world that's noisy. We do not consider ourselves mathematicians. I know that you're here for math camp, right? And that's great. We use a lot of math, but mathematicians think about things a little differently. They're more interested in generalization. There are applied mathematicians who do almost the same stuff that statisticians do. So there's some overlap, but it's a little different. But we would say we're not mathematicians. The other thing is you should take statistics. Maybe you'll get a chance to take AP Stat in high school. If not, you can certainly take statistics in college. It's really important for anybody who's going to do any kind of research or needs to read papers where people do research, because basically all research nowadays uses statistics, and you need to be able to understand what does it mean. Just even things like, have you done any kind of surveys or polls? Do people like Pepsi better than Coke? Stuff like that. How many of your friends use Facebook or Twitter? Have you tried to estimate that? Figure out how many people in your school have a Facebook account? Anything like that, when you're trying to figure out a proportion, it's a statistics problem. You're thinking about there's some big population that you want to learn about. So it's really important. Also, people are always trying to get you to buy things, and they're going to tell you, oh, you know, buy this thing and it'll make you happy. That's the basic reason for advertising. So they're going to give you reasons to buy things. If you know some statistics, you're going to be smart enough to think about, is that really true? The variability point is really important to us. The fact that if you all got the same number of fish out of the bag, I wouldn't have a job. Right? Statistics just depends on that variability. So I'm glad you didn't all get the same number. If you want to study more statistics, you should take 4 years or more. Some of you can get in 5 if you start algebra in 8th grade. Math in high school. Sciences are really important just to see the applications and understand what people are doing with them. Computer programming is important, and critical thinking skills are really important. I don't know if you've seen anything like this, but I should have a picture for this, but if you did a plot of when during the year are ice cream sales highest, and when during the year are murder rates the highest?
Oh my gosh.
It's the same time. So that obviously shows that when people eat more ice cream, they get more angry. You know?
Also, global warming is because of pirates.
Oh,
Since
I didn't know that.
1700, global warming has gone up at the same rate as pirates have been.
Bring back
So
pirates.
pirates kept things cool. Well, Johnny Depp's pretty cool. I have to say.
That's funny. I've never heard that one.
What do you think of that reasoning? Could it go the other way? Let's see, when there are more murders, people get worried, so they go out and buy more ice cream.
The ice cream brand.
Oh, it's a conspiracy. We always need more conspiracy theories. What else do you think? What do you think's going on? Coincidence, but it's a pretty strong effect. There really seems to be an association there. Yeah.
Maybe it's easier to kill people in the summer.
Easier.
Because they're gone.
Ah.
Easier.
Because they're gone, but you can't kill somebody if they're not there.
So it does, all sorts of violent crimes do go up in the summer. And so what's different about summer than winter?
There's no school.
It's cold. It's easier.
That's cool. That's good.
People don't see those attractions.
Yes. Some people do. They sell ice cream. It's in the store all year long, right? It's not like beach balls. You can't find a beach ball in December. Yeah.
Well, maybe this is kind of weird, but maybe in the summer they eat more ice cream, so then they're hotter in the summer, so it may be harder to like, it'd be easier to murder them because they don't have as many covers on.
In the winter, I was in Montana. Everyone's cooped up in their homes, but then in summer, they all start to go out. We're like bears hibernating, but then they start going out in the summer. And so then, when we're in summer, then we murder people.
Also, more people are like stressed and tense during fall, winter, spring, and most people relax more during the summer. So they're relaxed, the murderers end up behind the beach chair.
Well, I think. Yeah, we have one more here. Okay, go ahead.
Maybe somebody's angry because they didn't get the ice cream, so they kill the person who took it off. That's a good point.
Another one?
Well, I have one, I was thinking, how in the winter people get depressed, and then the ice cream sales would go down because it's winter, and then
Right.
in the spring I guess it's said that more suicides are committed, and then that's when the ice cream sale goes up because it's
Yeah.
warming up.
Yeah, so I think what's happening is generally there's more violent crime in the summer when it's hotter. So temperature does have an effect on crime, but I think it's just temperature that does both things.
Yeah.
Not that there's really a
Right.
connection here. So we call that a lurking variable. So you can go into sociology and understand that. If you really want a job as a statistician, you do need to do more than just 4 years of college. And I'm done and ready for your questions. Yes.
So other than the fishing, what other type of things do you do on a regular basis? And what do you do when you're not going out taking statistics?
So the nice thing about being a statistician is I don't go out and collect the data very much. And the pictures I showed you looked like it was a nice sunny day. When they actually do the data collection on these fish, it's pretty nasty weather. It's in the spring and the fall. And you're out there on the water and the wind's blowing and your hands get real cold. So it's really, the people who do it love it, but I'm not one of those. So I've also worked on things like insurance. How do you tell if somebody's cheating when they file claims for crop insurance? I've worked on the glass ceiling effect. Why is it that it looks like women get promoted to some certain level in companies and then it's hard for them to break through and get to the top levels? That was kind of a computer simulation more than statistics. We have other people in the department who work with grizzly bears a lot, people who look at time series data, avalanches, and